For this video, I just want to share for the topic of especially BGP local preference. Um, please don't mind that heading tuning BGP, which is actually just copy from the CBT nugget video. So I try to do this lab. It's been taking like 2 days. Just want to share with you, but I certainly find out lots of good things to know to share. So first I just want to clear all these notes on this uh, GNS3 my GNS3 topology screen. First I want to say is that there are some attributes like 13 attributes to play around in BGP, but as he stated in the videos, like saying that we are more focusing on for CCNP especially, we're more focusing on weight metric, and then of course local preference, very important to know, and um, and then so on. Okay, I just can't remember. So first, why we use the local preference? Why we need to use the local reference in between ISP and organizations? So the answer is here. Local preference is the industrial standard way of making which bet are better than others. It is the way to make the bets are better than others once compared with those routes coming into the organizations. Local preference coming in from primary router is higher local preference than others in an autonomous system. By the way, actually, local preference is a ruler. It's a rule in an autonomous system. It can influence over the routers, influence over the routers in the autonomous system. Um, okay, let's take a look on R3. Later, I'm going to show all my configurations in each routers. Show IP BGP. Local preference default is 100. You see for this route 150.1.50.0, you see local preference 1000. Whenever this route comes into the router 3, the local local preference 1000 value is um, its influence over the whole autonomous system 5500 by saying that I'm the one who owns the 1000 preference. So this is all the rest of the routers really prefer to take the routes. So as you see 1000. Okay, how are we going to set up to be able to influence the local preference influence over the other routes? First, we're going to set up the IP SSD, which is the name SSD. These are actually the steps I'm seeing on my GNS3 screen. So the step 1, step 2, step 3, and step 4, and then up to step 5. That is here. Actually, this is the step 5. So for these scenarios, we are actually doing for router 3 to be a primary path for 150 network over here. So the networks comes into this point and go and influence over the other routers to take and then traffic back to the router 3. That's what we are doing. And another one is router 2. We are going to do the router 2 as a primary path for the 200 networks, for the networks over here. So just take a look the configuration for the router 3. Why we are choosing router 3 is it's just to manipulate those routing configurations to be influenced over to the autonomous system into the organization actually. So first we just set up for the name main access list. So IP access list standard routes. This is actually name routes for router 2. We name it for router 2 as an IP access list standard. Then inside it we declare to permit 200 networks and another standard name access list that for routes for router 3 and to permit 150 networks. So after that, for the step 2, and we declare another naming is the route map. We name the route map as a local preference and permit 10 as a sequence actually for the first step. And then inside it we just to check to match the IP address into it. So saying that match IP address routes for router 3. The routes for router 3 just refer to access list. So to be able to match the IP address inside the access list, we just put this configuration into the route map local preference as a step as a sequence of 10. The mesh and set, it's always mesh and set. After we need to set is local preference value 1000. The higher is the better. The higher local preference the better for influencing the routes. So we set the 1000. And for router 2, route map local preference permit 20 as a sequence 20. So mesh IP address route for router 2 and set local preference 10. Once the routes are coming to this point, the router 3 it checked all the access lists and IP address. Then it pass out local preference with the value of 1000 into the network. For 150 network, it should be fine. All the others routers like R1, R2 going to response to R3 to be able to route into the R3. And for the 200 networks, once it's checked, it came in with local preference 10, but the R2 has the local preference as a default, the value is 100. So with comparing with 110, this 100 is always win. So R2 is at its own value, it's taking over the value of 10. So it doesn't change for the for the 200 networks to be able to take from router 2. So this is how it works. So just keep in mind, we need to keep in mind is, first we need to declare the access list, IP access list as name access list, and then second we need to do the route map and declare the route map name and the sequence number, and in it we have to match the IP address for those access lists. Then we have to set the local preference value as a step 4. Now after all it's done, just don't forget to put this command into the router BG and under the router BGP uh, autonomous system. We have to stick into it, into the router BGP. So by using neighbor 10.1.36.2, we just point it to the router 6 as a neighbor. By using 10.1.36.2, because we're using router 3 as a higher preference value, local preference values. That's why we're using router 6 for the neighbor. So neighbor 10.1.36.2 route map local preference in. So to be able to receive the whole networks from the ISP size, and by the router 3 we pointed router 6 as our neighbor routers. This is how it works for the local preference. Then once you check, okay, let's go back to the one thing I want to tell you this. Before I was really struggle to be able to ping from router 1 to router 5 the network 150, and to be able to ping from router 1 to router 7's 200 networks. I was really struggling. It's really easy commands just to implement into the router 1. So before that was like, I'll show you the configuration first. Show RAM. Okay, this is all the configuration inside the router 1. As usual, we declare the IP addresses. We implemented all the addresses into the interfaces as usual. Previously, I really forgot to implement these commands like redistribute connected. Without it, you cannot paint to the router 5 and router 7. So let's try it again. Now we can ping, and before we try it again, I just want to show my successful ping access into the router 5 and router 7. So okay, yes, by using trace route 150.1.50.1, we are now pinging to 150 networks. So as we manipulated before by using local preference, we have to use that traffic must go from router 3 from router 3 to router 6. As you see, 10.1.13.2, which is this interface. And after that, it goes to 10.1.36.2, which is this interface. Now after that, 10.1.67.2, which is this interface. Then what else? And then 10.1.57.1, which is this interface. Then we reach to that routes reach to the 150. Network, because it is according to the local preference. It goes by local preference value, as I said before. So okay, I'm going to trace route another address, IP address, which is 250.2.1, 250.2.1, 250.2.1. Now I believe it's gonna go to router 2, router 4, and router 5, and router 7, and then 200 networks. So as you see now, 10.1.12.2, this interface, 10.1.24.2, this interface, and 10.1.45.2, this interface, and 10.1.57.2, this interface, and 200 networks. This trace route is actually manipulated by local preference of router 3 for the network between router 2 comparison. Those routes are coming in from this way, and then it compares with the local reference value of 10, and then its original value 100, and then the 100 wins. So the route goes by this way. I wasn't able to do that before. Whenever I ping to those address, okay, now you see I can able to ping it. Because of this command, redistribute connected, you can able to ping. Before, I cannot able to ping. I can see those networks on router 5 and router 7. Let's remove this command. Redistribute connected. Redistribute connected means that whatever it's connected into this router 1. Okay, before I use this, let's check to show IP route. You see the connected. Okay. 10.1.13.0 and 10.1.12.0. Another one I just want to show is to show IP BGP. Whenever you see this question mark, it's incomplete, but actually it is because of redistribute command into the BGP. For this I is is actually for this origin code, which is saying that this route comes from IBGP, Internet BGP. This I means that Internet. IBGP. This R is origin code. What you see is question mark, which is we have used redistributed command. So now I'm going to move it. No redistribute commanded. What is going to happen? Let's check it out. Whenever you have changed the big changes, you have to use clear IPBGP asterisk. Then let's try to ping those routes. Okay, gone, no more. You cannot able to ping. So this one can't. You cannot able to ping. Okay, so we have to implement. Now you can check show IPBGP. All the question marks are gone, and it shows what is the difference between those. 10.01 and 12, 000, next up. Okay. This is because of router 2 has the command next hope set command. I'm going to show router 2 command. It says that whenever the routes comes into router 2, I'm the one your next hop. It's declared in the neighbor command. Neighbor 10.1. For the R1, the router 2 says that neighbor 10.1.12.1, I'm your next hop by myself. I'm your next hop. So to be able to broadcast the networks inside the routers. So as you see, neighbor 10.1 or 12.1, next host set. I am your next host. You can see the configurations. Okay. Now router 3. You see the difference? This is before. Sterix, feel it, best routes. Okay, to reach anywhere, next or anywhere. Now after we removed the command no redistribute connected, it shows ten or 1 or 24 or 0, which is this, and 10 or 1 or 36.0, which is this route. The next hop is 10 or 1 or 12.2, or 10 or 1 or 12.2. Turn on 12 or 1 or 12.2, turn on 1 or 13 or 2. So that's implemented again. It's just sharing notation. So you distribute candidates. And what you need to do, clear IP BGP storage. All the routes are back on again. And now you can able to pay. It's not too fast because BGP is a slowest protocol. Alright, later I show you again for the router one can be able to pay. So what else? Router full configuration. Router 2, router 3. So router 3 configuration. Router 4 configuration. Now it's able to ping. Takes a while. BGP is slowest protocol for the ISP to ISP. This router 4 configuration. Router 5 configuration. You see this question mark? It's using redistribute terminal. Okay. It's using the redistribute command on router 1. That's why it stays showing on router 4. Same. Router 5 configuration. Route map filter route map name. The permit 10 is the sequence. The mesh IP address is 50. 50 is 50 is access list. This is standard access list. 50 permit 150.1 or 50.0 or 5. 152.50.0. The mesh IP address 50. Route map is going to implement into redistribute route map, connect the route map filter. Okay. And then let's look at route 6. So yeah. One thing I just want to share is that if you use BGP default local preference 700, okay, just to use as a default local preference value 700. This is the command. Now after you use this command, what you're going to see on your router 1 outcomes by show IPBGP outcomes says that all the best route is took over by the value of local preference 700. Okay, all the best route took over with the value of local preference 700. Okay, for 150 and 200 networks. This is what you're going to see if you use this. Okay, this is router 6 configuration. Just simple configuration. Router 6, 10.67.0 mask. It's a network. Neighbor. It's declared. It's a network, neighbor networks from the different autonomous system. Network 10.1.67.0 for this. So this is the network from different AS, different autonomous systems 7.1. That's why we declare a network 10.1.67.0 mask default 0. As usual in R4. Just take a look at R4. 1.45.0 match to 45. So it's coming from different operating system. Okay. Order 6 configuration. Router 7. One thing I just want to share is MED or metric. Lower is the better. The rest attributes are higher is the better. I forgot. MED is a discriminator. Discriminator. Yes. So this is the router 7 configuration. You can give me a comments if I do anything wrong. You can correct me. I just will to welcome your thoughts and comments. Okay. Thank you so much for watching. This is just sharing, not teaching. For the router 7, just simply configuration. Nothing much. And now 200, just stick on the side. For the router 5, just see it again. Network camera 50.2.50. No. Maybe I do something wrong. I did something wrong inside the configuration. You can correct me at any time. Okay. Thank you very much for watching my video. Just sharing, not teaching. Thanks a lot.